Sampling techniques and the central limit theorem introduces essential statistical methods used to analyze financial data and make inferences about large populations based on smaller samples. In investment analysis, it is often impractical or impossible to examine every observation within a population, such as all investors, securities, or transactions. Sampling techniques allow analysts to collect representative subsets of data efficiently while still drawing meaningful conclusions. The topic emphasizes that proper sampling methods improve the reliability and accuracy of statistical analysis. Understanding sampling concepts is fundamental for research, portfolio analysis, economic forecasting, risk management, and hypothesis testing throughout quantitative finance and the CFA program. The topic begins by distinguishing between populations and samples. A population includes the complete set of observations relevant to a particular analysis, while a sample is a subset selected from that population. Analysts use sample statistics, such as sample means and variances, to estimate unknown population parameters. The topic explains that sampling introduces uncertainty because sample results may differ from the true population values. This difference is known as sampling error. Minimizing sampling error is critical because inaccurate or biased samples can lead to flawed conclusions and poor investment decisions. Proper sampling design therefore plays a crucial role in statistical reliability and financial research quality. Several sampling techniques are introduced in the topic, beginning with simple random sampling. In this method, every member of the population has an equal probability of selection, reducing the likelihood of systematic bias. Stratified random sampling divides the population into subgroups, or strata, and randomly selects observations from each group to improve representativeness. Cluster sampling selects entire groups or clusters rather than individual observations and is often used when populations are geographically dispersed. The topic also discusses convenience sampling and judgmental sampling, which are easier to implement but may introduce significant bias because selections are not random. Each method has different implications for statistical accuracy and reliability. The topic emphasizes the importance of sample size in statistical analysis. Larger samples generally provide more reliable estimates because they reduce sampling variability and improve the precision of sample statistics. However, increasing sample size also raises costs and data collection complexity. The topic explains that sampling distributions describe the probability distribution of a statistic, such as the sample mean, across repeated samples from the same population. Analysts use sampling distributions to estimate uncertainty and evaluate how closely sample results are likely to approximate true population parameters. Understanding sampling variability is essential for interpreting financial research findings and conducting accurate quantitative analysis. A major focus of the topic is the central limit theorem, CLT, one of the most important principles in statistics and quantitative finance. The CLT states that the sampling distribution of the sample mean approaches a normal distribution as sample size increases, regardless of the shape of the original population distribution. This result allows analysts to apply normal distribution methods to many practical problems involving sample means. The theorem is especially valuable in finance because market data are not always normally distributed. By relying on sufficiently large samples, analysts can still use probability-based inference techniques and confidence intervals for estimation and decision-making. The topic also explains the concept of standard error, which measures the variability of sample means around the true population mean. Standard error decreases as sample size increases, indicating greater precision in estimates. Analysts use standard error to construct confidence intervals and perform hypothesis testing, both of which are central tools in financial research and investment analysis. The topic further introduces resampling methods such as bootstrap and jackknife techniques, which estimate sampling distributions by repeatedly reusing observed data. These approaches are particularly useful when theoretical distribution assumptions are difficult to justify or when sample sizes are relatively small in financial applications. The key concepts from topic establish the statistical foundation for inference and decision-making in finance. Sampling techniques allow analysts to gather representative information efficiently, while the central limit theorem enables the application of normal distribution methods even when population distributions are unknown or non-normal. Concepts such as sampling error, standard error, confidence intervals, and resampling methods strengthen the reliability of financial analysis and research conclusions. These tools support many advanced applications throughout the CFA program, including hypothesis testing, regression analysis, risk estimation, and portfolio management. Mastery of sampling and inference principles equips investment professionals to analyze financial data rigorously and make evidence-based decisions.